Welcome back to ICT Every Day. Today we're looking at how devices actually find each other on the internet. Joining me is an ICT expert, Dr. Sherman Curry, to explain the difference between IP address and MAC address. Let's start with the basics. When a computer has a name, why does it need two different types of addresses?
Think of it like sending a physical letter. You need both the city/street address and the unique name of the person you are sending it to. IP address is the city/street address. This indicates the specific location of a device within a network hierarchy. Just as the street address changes if you move to a new house, your IP address changes based on which network, coffee shop, home, office you are currently connected to.
That makes sense. So if my IP address is constantly changing as I move between networks, who is actually in charge of keeping track of that? Do I have to manually update it every time I walk into a new office?
Have to do a thing thanks to a protocol called DHCP, Dynamic Host Configuration Protocol. Think of the network as a hotel and the DHCP server as the front desk. The request. When you join, your device shouts to the network, "I'm new. Can I have an address?" The assignment. The DHCP server replies, "Sure. Use this IP address for a while." The lease. This is a temporary lease. When you disconnect, the server reclaims that address to give to someone else. This automation is why you can move seamlessly between networks. Your device simply checks out of its old address and checks into a new one, keeping traffic organized and preventing address conflicts.
So if I got this straight, the DHCP server acts like a hotel front desk. When I arrive at a new network, my device automatically shouts an address gets a temporary lease for a room number. I mean an IP address, and then automatically checks out when I leave. This gives everything on it. I never touch a second worry about conflict. Did I get that right?
You've got the logic down perfectly. It's that constant, automatic check-in and check-out process that keeps the entire network running smoothly without you having to lift a finger.
That makes perfect sense for how I get my room number. But I'm still a bit confused about the hardware side of things. If my IP address is just a temporary label assigned by the front desk, how does the network notice my specific after it's talking to rather than someone else's device in the same room? Is there something more permanent than identifying my actual hardware?
It's the perfect question to bridge us to the next layer. While the IP address is our temporary room number, every single network device in the world has a permanent, unique identifier burned into its hardware at the factory. We call this the MAC address, the Media Access Control Address. Think of it as the unique name of a person in a mail. This is a fixed identifier tied to the specific hardware. No matter which house network you move into, your identity, MAC address, remains the same. It is used by switches to deliver data to the specific person device sitting on that local network.
I see. So the IP is my room number and the MAC is my permanent identity. But if the DHCP server gives me my temporary IP address, who or what is responsible for assigning that permanent MAC address to my device in the first place? It can't be a server, right?
Great distinction. Unlike your IP address, which is managed by a network server, your MAC address is assigned by the manufacturer. When your laptop or smartphone's network interface card, NIC, is created in the factory, the manufacturer burns a unique 48-bit code directly into the hardware. It's like a permanent serial number or a fingerprint because the manufacturer assigns it. The address is globally unique. No two devices in the world should ever have the same MAC address. This is why the MAC address doesn't change when you travel. It's a physical part of the hardware, not a setting configured by the software.
It's fascinating. So the manufacturer burns the MAC address into the hardware and the DHCP server assigns the IP address. But I'm still struggling to visualize how they actually work together in real time. When I'm trying to, say, open a web page, how do these two different address types cooperate to get that data from the internet to my screen?
Relay race with two different types of runners. The IP address acts as the long-distance runner, carrying the data across the vast, complex public internet and hopping from router to router until it finds the correct building, such as your home or office network. Once the data packet hits your local router, the IP address's job is effectively finished. The router then looks at your device's IP, identifies which physical device on the local network it belongs to, and uses the MAC address to sprint the data to the final destination, your specific laptop. It uses the Address Resolution Protocol, ARP, to translate that logical IP into the physical MAC address, ensuring the router sends the data to your specific port or Wi-Fi antenna rather than to your neighbor's printer.
Oh wow, I never realized they were such a perfect tag team, but if I were looking for a list of network configuration and data packets on my screen, how could I tell the difference between the two at a glance? They both look like a jumble of numbers and letters.
Quite simple to spot the difference based on their DNA. An IP address consists of 4 sets of numbers ranging from 0 to 255, separated by periods, and it looks like 192.168.1.15. It is purely decimal. A MACI address, however, is a 48-bit value written in hexadecimal notation using numbers 0 to 9 and letters A to F. It is typically written as 6 groups of 2 characters separated by colons or hyphens, looking like 0, 1A, 2B, 3C, 4D, 5E. Whenever you see letters in an address string, you know you're almost certainly looking at a MAC address.
Great tip. I'll definitely remember that. But wait, I've heard people mention IPv4 and IPv6 before. Are those just different versions of the IP address, or do they change how the whole IP versus MAC system works?
That's a crucial question. IPv4 and IPv6 are indeed different versions of the Internet Protocol, and the shift between them is all about scale. Think of it like phone numbers. IPv4 is like a local phone book that ran out of unique numbers because so many people, and now smart fridges and light bulbs, want to get online. An IPv4 address is 32 bits long, giving us about 4.3 billion possible addresses, which we have effectively exhausted. IPv6 is the upgrade. It uses a 128-bit address, which allows for a practically infinite number of addresses, enough to assign a unique IP to every grain of sand on Earth. While the transition makes the addresses look much longer and more complex, the fundamental tag-team relationship with the MAC address remains the same. The router still uses the IP to get data to your local network, and it still relies on the MAC address to deliver that data to your specific device.
To wrap it up, an IP address is like a temporary hotel room number assigned by a DHCP server to get data to the right network building, while MAC address is a permanent ID card burned into the hardware to route that data to a specific device. The tag-team effort lets you move between networks seamlessly, and IPv4 and IPv6 provide the massive scalable upgrade needed to keep the system running as more devices join the web.
Summary, it highlights how logical and physical systems work in harmony to keep every device connected, whether at home, work, or a cafe. Thank you for having me on ICT Every Day. It's been a pleasure breaking down these networking fundamentals, and we hope our listeners feel more empowered the next time they connect to Wi-Fi.